Hi everybody, and welcome to the first of our water supply talks. Today we are going to be talking about the water cycle, groundwater, and stormwater. My name's Tanya, and I am one of nearly 3,000 people that works for the Water Corporation. We work really hard every day to make sure that clean, safe, healthy water arrives in your homes, schools, and businesses. So let's pretend we are going to zip open the street and have a look to see what's really going on underneath there. You would find underneath our streets that there are 3 different water pipes. Each water pipe has got a completely different job. The first water pipe is carrying clean, fresh water into your homes, schools, and businesses. If we followed that water supply pipe all the way back to its beginning, it would come out at our dams, underneath the ground, and in the ocean. All of that water gets purified and then gets sent along that water supply pipe to your homes, schools, and businesses. We use that clean water every day for all sorts of different jobs. And as we use it, it gets really, really dirty. So that dirty water then goes down into what we call a wastewater pipe. Some of you might know the wastewater pipe as a sewer. So the wastewater goes along that wastewater pipe, and the wastewater pipe, if we followed it all the way to its end, it would come out at what we call a wastewater treatment plant, where it is purified again until it is ready to go back out into the environment. The third pipe system is the stormwater system. The stormwater system catches all of the rainwater on our rainy days, but also any water that we might use outdoors, for example, when you are washing your car. So to understand how all of those bits work together, let's have a look at the water cycle. Now, I know you all know the water cycle really well because we started teaching you the water cycle when you were in kindy and you sang the Incy Wincy Spider song. Yeah, that's actually a song about the water cycle. So the different parts of the water cycle, we'll start off with evaporation. As the water gets heated up by the sun, it will evaporate up into the sky, it will cool down as it rises, and it will condense to form clouds. Those clouds are constantly moved around the earth with the wind. And if the clouds get heavy enough and the conditions are just right, we will end up with precipitation, which might be in the form of rain, hail, or snow. The water cycle, though, is a little bit tricky because it doesn't share the water on earth very evenly. Some parts of the world are very dry, like our deserts, and some parts can be very wet. Most of Western Australia falls into the very dry category. So also part of the water cycle are the 3 different places that Water Corporation uses for your water supply. Because we get your water out of the dams, from underneath the ground, and also from the ocean. Water Corp's dams were mostly built by the mid-1970s. Unfortunately, they don't supply very much water into the supply system anymore. Our climate has changed a lot since the dams were first built. And that means that we've had a number of very dry winters all in a row. And so we haven't had much rainfall going back into the dams to top them back up. There is no person who stands on the side of our dams with a hose pipe to fill them all back up again for us when they get empty. And as the dams started running out of water, we realized at the Water Corporation that we would have to find water from a different place. And so we started looking to the water that sits underneath the ground. If you think about it, on a rainy day, the water doesn't just land on the ground and fill up and fill up. It lands on the ground and slowly seeps and soaks deep down underneath the ground, through layers of sand and soil, until the water finally reaches a really hard layer sitting underneath the ground, which is rock. Luckily for us in Western Australia, along most of our coastline, we get a totally awesome and amazing type of rock underneath the ground, which is limestone. Limestone is really the reason that we are able to use groundwater for your water supply. So I'm going to show you how absolutely amazing our limestone is. So I've got with me a nice big chunk of limestone, and when I hold it up, I know you've all seen this before. If you've been driving along a road and people have been digging holes anywhere along the side of the road, you will have seen them digging up big chunks of limestone. Now let's pretend that this piece of limestone is sitting quite deep under the ground. There are layers of sand and soil sitting above it, and it's a rainy day. So here's my rain cloud. We'll take the lid off the rain cloud. Right, so here's my rain cloud, and as the rain cloud's coming along, we're going to make it rain, and the rain's going to trickle through those layers of sand and soil, and watch what happens when it hits the limestone. Right, so I'm pouring a lot of it. Can you see any dripping off the side? Is there any coming out of the bottom? Right, so it's a very rainy day. And watch what happens when I tip the limestone sideways. Everything's vanished. It's disappeared. Well, it hasn't quite vanished. It must have gone somewhere. You all saw me putting the water on there, but if I turn the rock upside down, or I give it a big shake, nothing's coming out. The reason for that is that limestone on the inside looks a bit like a sponge. There are thousands and thousands of teeny tiny little holes inside there, and as I poured the water onto the limestone rock, the water was absorbed or sucked into all of those tiny little holes and spaces. It is so good at storing water that some of the water in our limestone under the ground of Perth has been there for millions of years. Now that this limestone is filled up with water, we can call it an aquifer. So an aquifer is an underground water storage system. So that's the easy part, getting the water into the limestone. So the water that sits underneath the ground, trapped in all those tiny little holes in the limestone, it can be quite tricky to get that out, especially if we are going to get it out of the ground in a sustainable way. And sustainable means you are not allowed to smash the limestone. So to get the water out of the ground, we use a machine called a bore. Many of you will have seen a bore in your gardens at home, at school, and even in your local park. So I'm going to build a bore for you today so that you can understand how it works, and you can do this later at home or with your teacher. To start off with, I've just got an empty jug, and we're going to build the aquifer in the jug. Now we need to pretend that this jug is representing what's going on underneath the ground. If we were to cut the ground open and pull it apart so that we could see all of those layers, that's what we're going to build into our jug. This is what we're using for our pump. You guys will have seen these at home. You'll find one in your shampoo bottle. And at the base of my pump, now this is what we're going to use as our bore. At the base of the bore, I put a bit of fabric and tightened it around the end with a bright elastic band. The fabric at the end of the pipe will make sure that we are not sucking up too many little bits, which will cause our pump to break. So that's our bore pump, and we're going to pop it just into our jug over here. The first layer that we're going to pop into our jug is the limestone layer. And I've got a whole lot of limestone rocks over here. You guys will be able to find these around your neighborhood too. We're popping those into the base. That's a bit noisy. Popping those into the base of our system. And you'll see between all of those bits of limestone that there are lots of holes and gaps and spaces. On top of that limestone layer, I'm going to put a whole lot of little pebbles. Those ones. And the pebble layer is going to sit on top of the big limestone rocks. And you will see that those pebbles have also filled in a whole lot of the holes and spaces between the limestone rocks. And the final layer that's going to sit on the top is our layer of sand. So we're going to pour the sand on the top. Watch how the sand trickles down into all those little holes and spaces between the limestone rock and all those little pebbles. See how it's trickling down into there and filling up all those spaces. So the last bit of our aquifer now is to put some water in there. So this is the water that's going to form the groundwater and get absorbed by all those limestone rocks. So we're going to pretend that it's raining, and we're going to pour a whole lot of water into our aquifer. And you'll be able to see as the water trickles down through all of these layers, you'll see the layers getting wet as I pour it in. Right, so now it's filled up nicely. There's lots of water in our limestone layers. So now that we've filled up our aquifer with all of that rainwater, we're going to switch our bore pump on. Now the bore pump's going to squirt the water out the end. So make sure that you've got a little container on the end to catch that water as it comes out. I haven't got 3 hands, so I'm not going to have one of those. You can see the water come squirting straight out of my bore pump. In real life, as the water comes out of your bore, it will either feed into your sprinklers, which will water your gardens. At the Water Corporation, we've got really big bores that feed that water off and send it to a groundwater treatment plant to be cleaned. Right, so we're going to pop our bore pump on now. Right, so this bore pump's working quite well. It's sucking water from out of the ground, from out of the limestone, and squirting it out the top. If you really want to make a mess of your aquifer, you can even add a few little coloured droplets, just like those ones. Pop a few of the droplets in as well, and those ones will represent things like pollutants. Now, we're going to talk about that a little bit later in the talk, and how those pollutants affect our stormwater and our groundwater systems. So you can pop a couple of droplets on the top there as well and pretend that those are pollutants. And watch how they get drawn down into the aquifer and will affect the quality of the water supply in there. So that's our aquifer experiment. And if you don't do one at school, you can maybe make one at home as part of your homework. One of the things with groundwater is that we need rain to keep topping it up. If we've got lots of bores going into the ground, sucking water out of the ground constantly, we need the same amount of rain during winter to keep that water level underneath the ground stable. But as I've mentioned, we're not getting nearly as much rain in most of Western Australia as we used to. And so the water underneath the ground is also decreasing. That meant that the Water Corporation had to be very innovative. We had to come up with a source of water that did not depend on the rain. And that's why we built a very large desalination plant in 2006. The desalination plants, we've got 2 of them now, they supply purified seawater into our water supply as well. So the desalination plants take salty water out of the ocean, clean it, remove the salt, viruses, bacteria, and then that clean water is also added into our water supply system. And now we're going to talk about what your roles and responsibilities are to help us care for the water supplies that we use for you every day. Remember when we zipped open the street? One of the pipes we found under there was the stormwater pipe. So the stormwater pipe catches all of the water that lands up on our streets, trickles down of our driveways, and comes out of our gardens, and disappears down the stormwater drains that you guys will have seen when you're walking or riding to school. The stormwater drains have got a very different system. There is no factory at the end of the stormwater drain. Any water that comes off your garden, washes off the streets, that water lands up directly back in the environment again. And depending on where you live, that water might land up in a river, a lake, a wetland, or even back in the ocean. Maybe you can have a think after school today about where your stormwater might end up and figure out where your closest waterway is. The stormwater, as it moves down through the stormwater pipes, collects everything that we might be using outdoors. So think of the many jobs that we do outdoors that might contribute to pollutants entering our stormwater drain. I'm sure you've all washed a car before. Well, I hope you have. And when you were washing your car, you would have used some soap. Now, if you've been washing your car in the driveway, some of that soap will trickle down your driveway into the street and into the stormwater system. Have a think about the number of poisons we use in our gardens. We don't like bugs and beasties eating our vegetables and our lettuces and our roses in our gardens. And so we have a number of different poisons to get rid of those pests. And those poisons we generally call insecticides. We also don't like weeds very much. And so we have lots of different kinds of weed killers that we also use in our gardens. If we use a lot of those, then some of the excess will also wash into the streets and enter our stormwater system. Don't forget about one of the worst pollutants that lands up in our stormwater, dog poo. If you've got a dog, we need you to make sure that you have plenty of dog bags when you are taking your dog for a walk, so that if it does more than one poop, you are well prepared to pick up the second one as well. The problem is when those sorts of pollutants enter the stormwater system, they can affect the natural fauna and flora. The plants and animals living in those waterways will be very badly affected by the pollutants that come from our gardens and from our homes. Now, we've got two pictures of a lake. Imagine we went to a beautiful, clean, healthy lake. The water is lovely and pure. There's all sorts of trees and reeds in the middle of the lake. We popped our hats on, took a sandwich, and sat in the shade of those trees for a while, really quietly. As we sat there, we would become aware of all sorts of amazing creatures that were living around us. There would be creatures that were living in the lake, creatures that were living and flying around in the reeds. You'd probably hear a couple of frogs. And if you looked up into the trees, you would see that there were birds and all sorts of creatures that live up in those trees as well. And that's the kind of ecosystem that we want to encourage. We want to be able to go to places where we can see our beautiful native wildlife. But if we add too many stormwater pollutants into the system, and those wash into a lake, they can make all of those amazing creatures and plants really sick, and often they can even die. For example, if you are using soap to wash your car and you use a lot of soap that enters the stormwater system, that soap affects the outer slimy skin of the frogs. If you've ever picked up a frog, you'll know that that outer skin feels very slimy. And that slime is there for a reason. It protects the frog. And as the soap comes into the system, it destroys that slimy layer on the top of a frog, and frogs can get really, really sick if that happens to them. As cars drive along the street as well, if they've got an oil leak, the oil drips into the street, washes off the street on a rainy day, and if that enters a wetland or a lake, and there are ducks and water birds that live there, the oil gets stuck in their feathers, and they can no longer fly particularly well. So oil coming off our streets can be a really bad form of pollutants. What about the dog poop? Well, dog poop has got really bad bacteria in there, and it's got lots of nutrients. And when those land up in our stormwater system and land up in a lake or a wetland, they can also cause a huge amount of damage, especially if there's some fish, frogs, yabbies, crabs living in that water. They will get sick from the bacteria and the nutrients coming from a doggy poop. And by their definition, pesticides and herbicides kill bugs and plants. And if we use too many of those poisons, they will really badly affect the insect life and the plant life at our wetland. So why am I telling you all of this bad news? Well, it's very simple for us all to make sure that those pollutants don't enter the stormwater system. An easy one, of course, is to make sure you've got your doggy poop bags when you take dogs for the walk. But part of your homework today is to have a look around your homes and in your gardens, and you'll probably want to take an adult with you, and have a look at the different products that you use. Are your products environmentally friendly? And if you're not sure what that means, ask an adult to read the labels on the back of your products. Have a look at your dishwash soap. Does it say on there that it is safe for the environment? There are all sorts of amazing pesticides and herbicides that we use today in our gardens that are not poisonous at all. I use a weed killer at home, which is actually just made out of vinegar. And vinegar is rotten grapes, and grapes are natural. So if we use those sorts of herbicides and pesticides around our homes, then we'll know that we are protecting the wildlife on the other side of a stormwater system. So today, hopefully you will understand how important it is for you to protect our waterways through the stormwater system. If you're not convinced, I would suggest you make some stormwater. Have a think about the different products that you might use around your home, and your adults at home can help you with this. Get a plastic tub, half fill it with water, and then start adding some of those products in there. See if you've got some soap from washing your car and pop a squirt of that in. Pop in a few different pesticides and herbicides. I don't think you'd want to put a real doggy poop in there, but you could use a bit of Play-Doh instead. And have a look at how that water starts changing color, how the smell changes. Have a look, some things will float on the top, some things will sink to the bottom. But just remember that if those are the products you're using in your home, they may very well land up back in the environment again. So today, I've outlined some of the jobs that Water Corporation does for you, and some of the jobs that you need to do too to protect all of those waterway systems that we get your drinking water from every day. And to end off, I am going to give you just an extra little bit of homework. So as I mentioned, one of your jobs will be to walk around your home with an adult and have a look at all the different products that you use around your home. And next time an adult goes shopping, maybe try and convince them to buy the environmentally friendly versions of whatever you use in your homes. I also want you to become more aware of how much water you use in your home. Remember where it's come from and how hard the Water Corporation is working to make sure that you do get fresh water every day. So your jobs are really important to help us do our job even better. And I want to thank you all for listening so beautifully today. I hope you've learned something, and I hope that you will go home and teach that something to someone at home.